Hey guys, here's a video on graphing rational functions. First of all, what are rational functions? So rational functions are equations where you have a polynomial in the numerator and you also have a polynomial in the denominator. So how do you graph these? Well, it's a bit of a process, but the good news is for the first part, it's just what you remember from the beginning part of the year, which is how to graph this. Now, when we graphed this, the first step was to factor it. And when we factor this, you have x plus 5x plus 2. Now, the next step is you're trying to find these values. These values are your x-intercepts because this is your x-axis. So your x-intercept will be points like something, comma, 0. The y value is 0. Same thing with this one, something, comma, 0. So we're looking for a value of x that's going to make this thing become 0. And in this case, you say, oh, if x is negative 5, that makes a 0. And if x is negative 2 plus 2 is 0, and 0 times anything is 0. So those are your two intercepts. So if you just graph this, it's going to look like that. Or maybe it'll look like this, right? But that was what we did at the beginning of the year. So it's the same exact thing, except it might have some things on the bottom. You're still going to have those same exact x-intercepts. So going back to this equation, because our equation is x squared plus 7x plus 10, and I factor it, I'm going to have intercepts at negative 5 and positive 2. Let's do another one. Going forward, I'll just put everything in factored form, just to make our life a little bit easier. All right, so let's say you have something like this. The question is, what are those intercepts going to be? And positive 3 goes to negative 3, so that's an x-intercept. Negative 1 goes to positive 1, that's an intercept. And positive 2 goes to negative 2. So we have those intercepts. Now we don't know what the graph does. It might do this, or it might do this, or it might do something really weird because of the bottom. We don't really know. But we know at least that it will go through those 3 points. It might do some other weird things, but at least we have one thing that is completely certain. It will go through those x-intercepts. Now let's talk about the bottom. Let's say we have some equation like this. Y equals, let's do 1 over x minus 2. If I graph this, let's start experimenting with some numbers here. Let's start with exactly 2. At exactly 2, if I plug this 2 into this equation, then that's going to give me y equals 1 over 2 minus 2. 2 minus 2 is 0. 1 divided by 0 is... we actually don't know. We can't divide by 0. So it's hard to graph something if we don't know what its value is. So let's pick something to the right. Let's do 4. Let's try 4. And we're going to do 1 over, instead of x minus 2, we're going to do 4 minus 2. And if I plug in 4, that gives me 1/2. And so when the x value is 4, the y value is 1/2, which is right about there. What if I do 3? If I do 3 and I plug it in there, then I get 1. What if I do 2.1? If I do 2.1, 2.1 minus 2 is 0.1. 1 divided by 0.1 is actually 10. When you divide by something small, you get a really big number. And so you end up getting this, and it goes all the way up there to 10. If I did 0.01 or 2.01, then I get 100. And you can see I can get as high as I want by getting as close as I want to 2. The closer I get, the higher I get. Now what if I approach this from the left-hand side? Let's try 0. If I try 0, 0 minus 2 is going to be negative 2, which is negative 1/2. And so negative 1/2 is going to be right there. If I do 1, 1 minus 2 is negative 1, which is going to give me that. So I end up at that point. If I do 0.9, then I end up with 0.0 or 0.1, 0.1, negative 0.1, which is going to give me negative 10. And so you can see on this side, it's going to come down like this. Okay, and that's true no matter how many of those I have. So if I have some equation like this, 1 over x minus 2, x minus 3, x minus 4, and I graph it, and this is 2, 3, 4, then I know the graph is going to be doing some freaky stuff along these lines. Okay, it's going to have to be zipping up like this, and maybe zipping down like that, or zipping over, but it gets really, really steep along those lines. So those lines have a name. They're called vertical asymptotes. Vertical asymptotes. And you get vertical asymptotes anytime you have a value on the bottom that makes it 0. So here, because 5 would make the bottom 0, then if I graph it at 5, I'm going to have a vertical asymptote. And the line, as it approaches it, is going to have to zip up, and then it's going to zip down like that. Or maybe it's reversed. Okay, now, the next part of this is testing points. So let's do that. So how do you graph something like this? X minus 2, x plus 3, x minus, well, let's make this easy. And on the bottom, let's do x minus 5, and let's do x plus 1. So when we graph this, let's start by graphing all of our asymptotes. So this is our x, this is our y. Now the value of x that makes the bottom 0 is 5. 1, 2, 3, 4, 5. And right here, the value of x that makes the bottom 0 is negative 1. So along these points, you have a vertical asymptote. And now on the top, these are the values of x that make the top 0, positive 2 and negative 3. 1, 2, 3. All right, so we have all of these different values. So our graph, we don't know exactly how it's going to go, but it might go something like this. It might go through here, it might go up this asymptote and down the other side of this asymptote and through this point and then down like that. That's a possibility. Or it could be right here. It could bounce off this and go up this asymptote, up this side of the asymptote, here, and then like that, right? We don't really know exactly how it's going to work. So what we need to do is we need to test points to the left and the right of each of these points. Now these points on the bottom are called critical points. Critical points are your x-intercepts and your asymptotes. Let's pick a value right in here. Let's pick negative 4. And let's see what happens when I plug in negative 4 into my equation. So if I plug it into my equation, then that's going to give me negative 4 minus 2, negative 4 plus 3, negative 4 minus 5, negative 4 plus 1. And negative 4 minus 2 is a negative number. Negative 4 plus 3 is a negative number. Negative 4 minus 5 is a negative number, and negative 4 plus 1 is a negative. A negative times a negative on the top is a positive. A negative times a negative on the bottom is a positive. So when I am in this region, anywhere to the left of negative 3, I'm going to be positive. So in this region right here, I am positive. Okay, what about what happens between negative 3 and negative 1? Let's pick negative 2. Let's test it and see if I'm positive or negative in that region. So if I plug in negative 2, let's see what happens. So if I plug in, hang on. Okay, negative 2, negative 2, negative 2, negative 2. All right, So negative 2 minus 2 is negative. Negative 2 plus 3 is positive. Negative 2 minus 5 is negative. Negative 2 plus 1 is negative. So now on the top, a negative and a positive becomes a negative. A negative divided by a positive is a negative. So now this region was positive. This region is negative. Let's see what happens in my next region over at 0. Okay, anything between negative 1 and 2, and it doesn't matter what point you pick, I'm just going to pick 0 because it's a nice, convenient number to pick. So let's plug in 0 and see what happens to those signs. One of those signs is going to flip. Let's see which one flipped on us now. We're going to do 0, 0, 0, 0. 0 minus 2 is negative. That was negative before. 0 plus 3 is positive. That was still positive. 0 minus 5 is negative, still negative. But 0 plus 1, this one now flips. So now you have a negative on the top, you have a negative on the bottom, and a negative divided by a negative becomes a positive. And so in this region between negative 1 and 2, my graph will always stay above the x-axis. It'll stay positive. Okay, now in between 2 and 5, you can pick any number between 2 and 5. Let's just pick 3. 3 seems like a nice number. Now again, when I plug in 3, what we're expecting is one of those values is going to flip on the bottom. Let's see which one's going to flip now. Let's plug in 3. All right, and we see our flipper, 3 minus 2. 3 minus 2 is a positive. 3 plus 3 is positive, that stays positive. 3 minus 5, that stays negative. 3 plus 1 is positive. So now a positive and a positive on the top is a positive. The bottom is a negative, and so the resulting sign is going to be negative. So in between 2 and 5, I'm negative. Now what happens from 5 onwards? Well, from 5 onwards, let's just pick a number like, I don't know, let's pick a nice round number like, let's say infinity. All right, we're only worried about this sign here. Infinity minus 2 is positive, that stays the same. Infinity plus 3 is positive, that stays the same. This is the one that flips. Infinity take away 5, it's still a positive number. Infinity plus 1 is still positive, everything is positive. So in that region, everything is positive. So we have minus, positive. Okay, so how are we going to graph this now? Well, when we graph it, let's clear off all of this stuff. And we remember that as long as we're to the left of negative 3, we're a positive number. So I'm going to just start drawing here, and let's say here I have a positive number. So I'm a positive number, I'm getting close to here, and I know I have to touch that point. So I'm going to go down and touch that point. Now once I'm here, can I bounce up again? Nope, because this is negative. So that means I've got to go down. So I'm down. I'm getting close to this asymptote. When I get to the asymptote, can I go up the asymptote? And the answer to that is no, I can't go up the asymptote, because if I went up the asymptote, I would have another x-intercept. And I only have 2 x-intercepts. I can't go adding new x-intercepts. So I can't go up the asymptote. When I get to here, I've got to go down. All right, now I'm going to redraw that, just make it a lot nicer looking. It's probably going to look something more like this. It's going to come down like that. Okay, now when I am over here on this side of the dotted line, I have to be positive. So that means if I'm going here, it's got to go up the asymptote like this, right? It can't ever go down it can't go down the asymptote, because if it went down the asymptote, then it would be negative. And everything to the right of negative 1 is always positive. Okay, so here I'm going to go up the asymptote like this, and now I get that value. Okay, now once I'm here, I'm in negative land, and I get to the asymptote, and again, because this is negative, everything between 2 and 5 is negative, that means when I hit the asymptote, I have to go down the asymptote like that. And then finally, right here, everything is positive to the right of 5, so it's going down the asymptote like this, and it'll just kind of go and eventually get closer and closer to the x-axis, but never quite. Actually, it'll go to an asymptote of 1. We'll talk about that later. Okay, so let's do one more. This one, I want you to test all the values on this one. So let's do something a little bit shorter than the one I just did. Let's do x minus 2, x minus 1, x minus 3. And number 1 is I want you to think about where your x-intercept is. Great, if you said 2, that's exactly right. Next, I want you to think of what are your 2 vertical asymptotes. Excellent, if you said 1 and 3, then you are exactly right. This is 1, and we have 3. Okay, so we have our x-intercept, which is the value of x that makes the top 0, and you have your 2 vertical asymptotes, which is 1 and 3. Now the next step is you need to test values in those different regions. We need to test a value to the left of 1 on this side, and then we need to test a value between 1 and 2 in that space. Then we need to test something between 2 and 3 in that space, and something bigger than 3 in that space. Now what I want you to do is I want you to pause the video and choose a number to the left of 1 and plug it into this equation right there. And tell me, is it going to be positive or negative? Okay, so I don't know what number you picked, but I'm going to pick 0. And it doesn't matter what number you picked. As long as it's to the left of 1, we're all going to get the same answer here. All right, 0 minus 2 is negative. 0 minus 1 is negative. 0 minus 3 is negative. And if you have a negative and a negative on the bottom, that becomes a positive, that becomes a negative. So everything in this region is negative. Okay, let's go and check the region between 1 and 2. So I need some number between 1 and 2. Go ahead and pick a number between 1 and 2 and plug it in. Okay, so I don't know what number you picked, but I'm going to pick 1.5. And when I plug it in, 1.5 minus 2 is still negative. 1.5 minus 1, though, now this one changes that guy to positive. 1.5 minus 3 is negative. So now I have on the bottom here, I've got a negative. And a negative divided by negative is a positive. So everything here is positive between 1 and 2. Let's check between 2 and 3. So pick a number between 2 and 3 and tell me what the sign is. Okay, let's try 2.5. And if I try 2.5, minus 2 is going to be positive, so that one flipped. 2.5 minus 1 is positive, 2.5 minus 3 is still negative. So I have a positive on the top, I've got a negative on the bottom, that's going to make the whole thing be a negative. Okay, finally, let's pick a number to the right of 3. So pick your number to the right of 3 and let's compare answers. Okay, I chose 7. Let's try 7 and see what happens. If I plug in 7, then 7 minus 2 is positive, 7 minus 1 is positive, 7 minus 3, well now that's big enough to flip this one. Anything bigger than 3 flips this thing, so anything bigger than 3 flips this. So 7 is bigger than 3, 7 is going to flip that. Now I have positive over positive, everything's positive. That means that things are positive on this side. Okay, so now when I graph it, what's that going to look like? Well, that means right here I am negative. So to the left of this, I'm negative. So because this is negative, if I'm right here in negative land, and I head to my asymptote, I have to go down the asymptote. Let's make that a little bit better. It's going to go down the asymptote. Okay, it has to stay negative. And you know it approaches infinity when you get to a vertical asymptote. On this side, I'm positive, so I'm going to go like this. Okay, now I go through this value. And then once I cross 2, I'm in negative land, so I have to stay negative. When I hit the asymptote, I go down like that. And then finally, when x is greater than 3, then I'm going to be positive, and so it's going to be going up the asymptote like that. Okay, I think that's probably good. Now, just remember, it's not always going to flip negative, positive, negative, positive. You might have something like this. And if you have something like this, if you have a squared on the bottom, it's going to look something like this. It's going to go down both sides. So it's negative, negative on both sides. So the other thing that we should talk about really quick is what are called holes. Let's say you have an equation like this. Y equals 7x minus 2 over x minus 2. If I'm following the same process as before, I'm going to say that there is a vertical asymptote at 2, which means the graph is going to go like this, and it's going to go like this at 2. But by the same measure, it also has a x-intercept at 2, which means it goes through that point right there. So it's at infinity, it's at negative infinity, and it's at 0 at the same time. So how do you deal with that? Well, let's do this. Let's find some numbers to the left and to the right of 7. So let's choose a number like, I don't know, 5. So if we choose 5, and we plug 5 in on the top and the bottom, and we get 7, 5 minus 2 is 3. On the bottom, 5 minus 2 is 3. The 3's cancel out, and you have 7. What if I chose a number like 6? If I chose 6, then 6 minus 2 is 4. 6 minus 2 is 4, and the 4's cancel out, and I have 7. What if I do 2.1? Well, if I do 2.1, then it'll be 2.1 minus 2. On the bottom, it'll be 2.1 minus 2. And then 2.1 minus 2 is 0.1, 0.1, and those cancel out, and I'm just left with 7. So what happens here at 2, it's not a vertical asymptote. It's also not an x-intercept. It basically is nothing. Does that mean that at 2 it's defined? Let's see, if we plug in 2, 2 minus 2, 2 minus 2, 2 minus 2 is 0, 2 minus 2 is 0, and then 7 times 0 is 0, so it's 0 divided by 0, which is undefined. So this is what's called a hole, and the way we draw it is this. We draw this open circle right here, which means that at exactly that value 2, it's undefined. Okay, so final one. Let's do this. Let's do x minus 3 over, let's do it x plus 1, x minus 3, x minus 1. All right, so first of all, let's identify the hole. These guys pretty much cancel out, but we have to remember that in our graph, x does not equal to 3. That means 3 will not be in our domain. There will be a hole at 3. So let's graph it. This is your x-axis. This is your y-axis. At positive 1, we have an intercept. At positive 1, we have an asymptote. And at negative 1, we have an intercept. So we have to test the values to the left of negative 1, in between negative 1 and 1, and to the right of 1. So let's choose a value to the left of negative 1. Let's try negative 5. Okay, so if we do negative 5, we're going to do negative 5 plus 1 over negative 5 minus 1. Negative 5 plus 1 is negative. Negative 5 minus 1 is negative. Negative over negative is a positive. So when I am to the right of negative 1, I am positive. So I'm positive here. I'm going to hit this one. And now let's choose something to the right of negative 1. Let's try 0. If I plug in a 0, then I'm going to do 0, 0. So 0 plus 1, that flips this one. That makes a positive over a negative, which is going to make that whole thing become a negative. So I'm at negative. I hit the asymptote. I go down the asymptote. Now let's pick a number to the right of 1. Let's pick 10. If I do 10, then 10 plus 1 is 11, which is positive. 10 minus 1 is 9, which is positive. Positive over positive is positive. So on this side, it's positive. So it's going to go up the asymptote like that. Okay, so now my graph looks like this. It goes down the asymptote here, goes up the asymptote here, but remember, x can't equal 3. So right here at 3, I'm going to go in, I'm going to draw an open circle right at that point, which is just tells me that that point is not defined. Okay, that's everything. Hopefully this makes sense. If not, come find me and ask me questions.